Hey, what's going on, guys? Let's do this problem right here. The first question is asking the mass is attached to an ideal massless spring. When the spring is set to motion with amplitude A, it has period T. What is the period if the amplitude of the motion is increased to 2A? So if the amplitude is doubled, what's going to happen? So let's see. So we have the first question. Let's write the equation for the period first. Period is equal to 2 phi square root of m over k, right? So we have mass spring constant and this 2 phi, but there's no dependency, like this period is not depend on the amplitude, right? Therefore there's going to be no change. So when the amplitude is doubled, period is still going to be t. So there's no change in period because not depend on amplitude, right? So the answer is going to be t. If it's increased by 2a or whatever, it's still going to be t. And then the second question is asking the mass on a spring has angular oscillation frequency of 2.8 radians per second. Mass has a maximum displacement when t is equal to 0 second of 0.23 meter. So this means that this is the amplitude, right? When they say maximum displacement, it means this point right here. So that is our amplitude, and that's 0.23 meter. And if the spring constant is 46 Newton per meter, that's K. And what is the potential energy stored in the mass spring system when t is equal to 1.4 second? So let's see how we can calculate. So since they are saying about potential energy, we know that potential energy in a spring is going to be equal to half kx square, right? Kx square. We know the k, but we don't know the displacement. We have to calculate. So let's put the displacement equation right here. X is equal to a cos omega t plus phi. Here's no shift provided, so we can eliminate this one. So whatever the value we get right here, that's going to be the x. So amplitude is 0.23, and then we have cos omega is angular frequency, that is provided 2.8, right? So this is going to be 2.8 times the time is 1.4 second, multiplied by 1.4 second, and that's going to be our x. So if we plug all the values, half times k, that is constant, spring constant, that is 46 Newton per meter times x square. So this is going to be 0.23 cos 2.8 times 1.4 second. This 2.8 is radians per second. This is second, and this is meter, right? This is in meter right here. So this is in meter, and if you square all of them, all of this value, that's going to be x square. So if you calculate this value, this one comes out to be 0.62 joule. So that is the potential energy when this happens. And the third question is asking the third question is asking a 2 kilogram block on a frictionless table is connected to two ideal massless spring with spring constant K1 and K2, whose opposite ends are fixed to the walls as shown in the figure. So in this picture, what is the angular frequency of the oscillation? K1 is equal to 7.6, K2 equal to 5.0. Let's see. So omega is equal to square root of K over M. So whenever they give the constant, like two constant like this, what we do, we just simply add them together. So this is going to be 7.6 plus 5.0 divided by the mass, that's 2 kilogram, and that's going to give us, that gives us 2.51 radians per second, and that is going to be the angular frequency. Let's do the fourth question. So we have a wave right here. Standing wave is oscillating at 690 Hertz on a string, as shown in the picture, right? What is the wave speed? So they're asking for the velocity. V is equal to f lambda. We know the f that's provided 690 hertz, and here we have 1.5 wavelength, right? Because this is one full wavelength and this is half wavelength right here. So full wave, so this is lambda right here. So we have full wavelength and half wavelength. So we can say 3 by 2 lambda, right? 1.5 lambda, that is equal to 60 centimeter. Therefore lambda is going to be equal to 60 times 2 divided by 3, that's going to be equal to 40, right? 40 centimeter. That's going to be equal to 0.4 meter. And if I multiply this one by 0.4 meter, that's going to give us the velocity. And velocity comes out to be 276 meter per second. And that's how it's done. I hope you guys like this video. See you next time.